I'm Ted Scambos. I'm the lead scientist at the National Snow and Ice Data Center. It's a part of the University of Colorado. What I do at the NSIDC is work mostly on satellite images and fieldwork of the ice sheets at either end of the Earth, Greenland and Antarctica. A lot of the work that I've done has been on these ice shelves which surround these large ice sheets. They're thick plates of ice that float on the ocean, and they're very sensitive to climate change. In particular in Antarctica, in the part of Antarctica that's just south of South America, that long peninsula that sticks out of Antarctica, we've seen some huge changes in these ice shelves. Over the last 20 years or so, temperatures have climbed remarkably, much faster than elsewhere on Earth, up to 5 times as fast, so that in just 20 and 30 years we've seen warmings of 2 and 3 degrees Fahrenheit. And because of that change in temperature, these ice shelves, which used to be stable and had been stable for thousands of years, are now starting to disintegrate. Now, what happens after they disintegrate, because of a combination of melting from underneath and melting on top, what happens after they disintegrate is that the ice that used to flow into these thick plates that push out over the ocean, that ice doesn't have that plate of ice in front of it to slow it down, so the glaciers pick up speed. And that's the part that's really critical. That's the part that means something to all of us in the US and everywhere on Earth, because that trigger, having the ice shelves disappear, is a major part of accelerating the ice flow off the ice sheet and contributing to sea level rise. And sure enough, what we've seen in the peninsula is that the glaciers that used to feed these ice shelves, they were called the Larsen B ice shelf, the Wilkins ice shelf. You can look it up on the web and see the events that have happened. When we've looked at glaciers that used to feed these ice shelves, after the ice shelves have broken up, they've accelerated. They've accelerated tremendously by a factor of 4 and 5 and 6 times the speed that they had before they broke up. That was totally unexpected. If you'd asked people back in the 90s or in the 80s how this was going to go, people would have said you might see a small increase down by the point where the ice flows out over the ocean. That area would accelerate a little bit, maybe a factor of 1.5 or 2. Instead, what we've seen is that these ice sheets are able to respond very rapidly and in a big way to climate changes at the front of the glacier. Climate changes and ice changes at the front of the glacier. This is also happening in Greenland, and in fact Greenland might be a little bit more of concern because in general that ice sheet is a little bit closer to the limit, to the point where it's warm enough to really start changing. Most of Antarctica is so cold that even if it warmed quite a bit, things really wouldn't change. They wouldn't get close to that critical freezing point in summer. The warmth of summer brings it to the freezing point, and things can really happen fast. So both ice sheets are changing. In the Antarctic, it's only in that peninsula so far. In Greenland, most of the southern half of the island is changing. And all of these areas are showing more ice flowing into the ocean and contributing to sea level rise. Now at this point, there's not a lot of contribution to sea level rise. Sea level is rising by just a few millimeters every year, a trivial amount. But we've already seen it start to increase. Now when you think about that, when you think that after hundreds of years of moving at a certain rate, melting in the last decade and the last 15 years has begun to change the level of the sea in a perceptible way. It gives you sort of a sobering thought about the future, because we are just getting at the beginning, just starting on this globally warming world that we're in for the next century. We have a lot to do in terms of addressing the input to greenhouse gases and the causes of warming. But in any case, we are going to have a warmer climate in the near future. How much warmer is up to us to decide. We are going to start to see sea level rise rates increase, and by the second half of the century, that total rise level and the rate of rise will really begin to become a concern for very low-lying areas in America, in Europe, in Asia. All of these areas will be impacted by inundation by the sea and by more difficulty with things like storm surges. A slightly higher sea level and an increased storminess. One thing I want to add, we're in for some climate warming no matter what we do, but in terms of looking at the future and estimating how much warmer it will get, I want to emphasize that things won't turn around, things won't change until we as a country, as a state, as a world decide to do something about it. We can make forecasts for the end of the century or 50 years from now, and you know, they may be accurate, they'll have a certain range of estimation, The real message that we're trying to get out is that this warming is not like the past ones that the Earth has gone through. And the Earth has been warmer and cooler from time to time in the past few thousand years, in the past few 100,000 years, millions of years. There's been lots of change. Now this warming is different. It's different in two ways. One, human beings have a big part in causing it. And two, there's 7 billion people living on Earth that are dependent on climate pretty much the way it is. We don't know how climate will be affected in detail. We know that because we've got so many people living on Earth and we're using so much of the world's natural resources in so many areas, even a slight toppling or tipping or changing of how we use those resources because of climate can have a huge impact on a lot of people. And because it can have an impact on a lot of people, it means it's important to all of us because those people are going to be desperate for resources, desperate for food, for water, for a better place to live, a better way of life. Every country on Earth is going to be impacted by this, including Colorado. I think Colorado is already pretty in tune with the need for further conservation, a look at how we use energy, a look at what we can do to change how we use energy, more mass transit, biking, doing things differently in terms of how we use our car, what cars we own. I think Coloradans have a good idea of what to do, and doing it takes time. More than that, I think we need to elect officials, and we have some in Colorado that are taking this very seriously. We need to make sure that message, if that's what we want, gets through at all levels of government, that all levels of government begin to address energy use and where energy is going to come from in the future, and also address the potential for climate change and addressing the impacts of climate change, like increased frequency of drought or increased storminess that may be more of a feature in the future. I think one thing that I hope Coloradans are doing is staying aware of the problem and what changes are going on and what the anticipation is for the future. It's a tough field to stay on top of because there's a lot of talk about it. And in the scientific community, we're used to a lot of back and forth about how important certain things are. They don't always work well. When they're boiled down to sound bites, they sound like they're conflicting. For example, if Antarctica warms up, more snow will fall there and so sea level will go down. Oh no, if Antarctica warms up, the ice around the edge will melt away and glaciers will flow into the ocean. Both are actually true, and the debate on the scientific side is which one is going to dominate. In the long term, we know that when the Earth warms up, the ice sheets get smaller. We've seen that in the geological record. In the short term, you could have one edging out the other, at least for a short period of time. It can sound like it's conflicting ideas, and it's tough to stay on top of it, but it's important that we as a community stay on top of it and understand what changes are happening and what the current discussion is about the causes and how fast this is going to go. I think that's something that NSIDC, the place that I work at, has really done well at showing that for most of the polar regions, events are happening faster than we anticipated, and it underscores the need to make changes now. Planning for changes by 2050 really doesn't help solve the problem. We need to say what we're going to do in the next 10 years, and I hope that we'll set the mark fairly high about what we're going to do in the next 10 years, because what I've seen in the Arctic and in the Antarctic is that we don't have any time to wait. We're going to be in for very major changes decade after decade, eventually at a scale where we won't be able to easily turn things around or stop or get back to a climate that we were happier with in the past. Things will already be on a roller coaster ride in which there'll be a lot of impacts to people all over the world. I know that NSIDC had a very important paper that came out talking about how effects that we observe on the ground are happening at a faster pace than those models anticipated, and what's wrong with these models, why couldn't they do a better job. That really is not the real message we want to get across. It's true that the observations on the ground are going faster than forecast by the models, but the models are extremely sophisticated, and they're also developed over decades. They tend to be conservative in that they don't want to have, it doesn't do any good if you wind up with a model Earth that does things that we know are very unlikely in the near future. So they tend to keep things within the range of climates we think we know, we understand on Earth. Now, all of those guys that worked on those IPCC models, and several of them are here in Boulder, up at NCAR, are working to improve them and adjust them and have them represent what we're seeing on the ground. The last 20, 30 years of climate warming are a great natural model for us to use to adjust these things so that we get a much better forecast for the next century. And I know they'll get there. And we're going to continue to monitor things, mostly an observational focused group at NSIDC, and keep track of exactly what's happening, what are the underlying causes in terms of climate change that lead to Arctic sea ice melting very fast, ice shelves disintegrating in Antarctica. All those things have causes that are based in climate. We're going to try and identify those and then tell the modelers, this is how we see it progressing in this area or that area, and we think these are important components of what changes are in store for us. I want to say it just that way, a personal guess as to what things will be like. I don't want to give the impression that I know for sure. I think things are going to be drier, particularly in summer, because of a shift in the desert belts around the world. Drier not just in Colorado, but in the southwestern U.S. as a whole, and in Europe and parts of Asia. I think you'll see an increase in intense hurricanes, although it won't be as though we have a hurricane every week, but there will be a noted increase in them on that time frame, 10, 30, 50 years. And probably the insurance companies will take note of the fact that it's costing them more and more for this stormy weather that we're in for. I think we'll see the last few glaciers in Colorado finally disappear. That will marginally impact water resources. We will have to plan differently for our water resources because we'll have less snow falling in general and more rainfall. Now that may or may not by itself change how much water we get, although I think it'll be drier. It'll change how we have to store water and distribute water because we're used to it being stored in a snowpack, and there may be less of that. It may fall more as rain in Colorado. I think we'll also probably see it's possible we'll see some pressure from the coastal areas and hotter areas of the country as they want to move to the relatively cooler and easier to handle Colorado. We could see a lot of influx of people. I think in general Colorado is not in severe danger like some places might be. For example, Southern California and Arizona, where the water resources are really scarce. But we will definitely feel impacts. We'll notice a difference. Maybe the most visual one, the one that'll really hit us in the gut, is the fact that we'll probably lose those last few glaciers we've got up in the mountains. And in fact, Colorado is really well positioned for that, as Governor Ritter said many times. We have great wind resources out on the eastern plains. We have great solar power capabilities, both high temperature solar and solar photovoltaic. We also have a real potential, I think, for carbon sequestration from coal plants. I'm going to go out on a limb a little bit. I don't know exactly what this would all cost, but we have several reservoir rocks, sandstones, out in eastern Colorado that could serve as places to store CO2 from power plants. Those gas fields are declining. It's possible to actually accelerate production from those by injecting CO2. That's been done in many places. And they're a short distance away from a lot of the places that use energy, mostly from coal-fired plants in Colorado. So I'm hoping that I'll hear some sort of a program to explore how to sequester the CO2 that we produce from all our coal-fired plants, because we're going to be dependent on coal for energy to a high percentage for a while to come. I want to see more, I'd like to see more wind and more solar be a part of our picture, and we're well positioned for that in Colorado. But the reality is we also have a coal energy source that really won't go away, and we need to do something about that too. I think there's several levels of meaning of clean coal. Many times, and this is another point for people to keep listening carefully, many times when they say a new fossil fuel is clean, that a technology has been developed to burn it more cleanly, what they mean is that they've removed other components which are damaging to the environment, like sulfur, like nitrous oxide, that is no longer an output from the coal plant. But to be clean from a greenhouse sense is a much taller order, And for a coal-fired plant fundamentally to be clean calls for a major change in how we handle either the exhaust or how we handle the burning of the coal in the furnace. So, and I think the way to do it is handling the exhaust and injecting it into the ground or under the ocean in some places, or possibly converting it to a mineral. I think Colorado will be one of the forefront leaders in adapting to climate change. People here have a strong sense of the environment on both sides of the aisle in the state, on both sides of the political discussion. I think both of the candidates nationally this year and even at a lower level have more of an awareness of climate change. They want to do something. I think there'll be varying speeds and degrees of urgency expressed by the different parties. But I'm optimistic that Colorado in particular will probably lead the way.